Good morning, students. Today we'll study about the classification of elements and periodicity in properties of class 11th, unit 3rd. Why do we need to classify elements? At present, 118 elements are known. It is very difficult to study the chemistry of all these elements and their large number of compounds. Systematizing the knowledge about the properties of elements and their compounds led to the classification of similar elements into groups and the development of periodic law and periodic table. Periodic table may be defined as the arrangement of all the known elements in such a way that the elements with similar properties are grouped together in the same vertical column. Historical development of periodic table. Genesis of periodic table. Deberneur's triads. In 1829, Debernier arranged certain elements with similar properties in groups of three called triads. The atomic mass of the middle element was nearly equal to the mean of atomic masses of the other two. Tabernier's relationship is referred to as law of triads. You can see the triads first in the case of lithium, sodium and potassium. The sodium mass is average of the lithium and potassium. Similarly, in the second triads, chlorine, bromine and iodine, the mass of bromine, which is 80, which is average of the mass of chlorine and iodine. This concept could be applied only at a limited number of elements and was thus discarded. Newland's law of octave. In 1865, Newland observed that when the higher elements are arranged in increasing order of their atomic masses, the properties of every eighth element were similar to the first element, just like musical notes. This generalization was used as Newland's law of octave. Lithium, we take the lithium, for example, if it is first element, then second beryllium, third boron, fourth carbon, fifth nitrogen, sixth oxygen, seventh fluorine, and the eighth again element is your sodium, which have similar properties with the lithium. So every eighth element, if we take beryllium, from the beryllium the eighth element will be magnesium. So both these have similar properties. This generalization was successful only up to calcium, but could not be extended further. Moreover, with the discovery of noble gas elements, the above sequence was disturbed and the arrangement was no more valid. Lothar-Mayer's atomic volume curve. Lothar-Mayer in 1869 plotted a graph between the physical properties of the elements such as atomic volume and atomic masses. He found that elements with the similar properties occupying the similar positions in the curve. For example, most electronegative elements of called halogens, fluorine, chlorine, bromine and iodine, occupy the ascending position of the on the curve. The most electropositive element called alkali metals Lithium, sodium, potassium, rubidium, cesium occupy the peak of the curve. Comparatively less electropositive elements known as alkaline earth metal, beryllium, magnesium, calcium, strontium, barium occupy the descending position of the curve. Thus, the Lothar-Meyer conclude that the physical properties of the elements are related to their atomic masses. You can see in the graph Lothar-Meyer's atomic volume curve. It is a graph between the atomic volume and atomic masses. The peak positions were occupied by the electropositive elements. The alkaline earth metal, they occupy the descending positions, and the electronegative elements, they occupy the ascending positions of the curve. Mendeleev's periodic law and Mendeleev's periodic table. Mendeleev periodic law states that the physical and chemical properties of the elements are periodic function of their atomic masses. Mendeleev arranged the elements in order of their increasing atomic masses, grouping together elements with similar properties in the same vertical column or a group. Mendeleev periodic table consists of 9 vertical columns called groups. These numbered as 1 to 0, 1 to 8 and 0. Group 1 to 7 subdivided into group A and B, subgroups A and B. Group 8 contains 9 elements in 3 rows, each containing the 3 elements. Group 0 consists of inert gases and were not known at the time of Mendeleev. Second, horizontal rows called series of periods. Series or periods, these numbered from 1 to 6. Importance of Mendeleev's periodic table. Systematic study of the elements. Mendeleev arrangement of the elements into groups and periods made the study of the element easy and systematic. Prediction of new elements. Mendeleev left some gaps in this periodic table for undiscovered elements. He also predicted the properties of the elements even before their discovery. For example, gallium and germanium were not known at the time of Mendeleev. Mendeleev left the gaps under the aluminium and silicon and named these elements such as Eka aluminium and Eka silicon because he believed that these would be similar in properties to aluminium and silicon respectively. Later on, these elements were discovered. Their properties were similar to the predicted by Mendeleev. Thus, the Mendeleev periodic table helped in discovery of the elements. Correctness of doubtful atomic masses. Mendeleev periodic table has helped to correcting the doubtful atomic masses of some elements based on their position in periodic table. For example, the atomic mass of beryllium was corrected from 13.5 to 9. This is the modified Mendeleev periodic table from group to 8, 1 to 8, and 0 group is inserted later on. 1 to 7, it is groups, they are divided into 2 subgroups. You can see this is A subgroup, this is B subgroup. Defects in the Mendeleev periodic table. First, position of hydrogen. Hydrogen has been placed in 1A along with alkali metals, although it resembles with halogens also. Anomalous properties, anomalous pairs. Although the elements in Mendeleev periodic table have arranged in order to increase atomic masses, but certain elements with a higher atomic masses are placed before the elements with the lower atomic masses. For example, argon atomic mass is 39.9 comes before potassium atomic mass 39.1. Similarly, cobalt atomic mass 58.9 comes before nickel 58.7. These pairs of elements are known as anomalous pairs. No justification has been given for such anomalous position. Position of isotopes. Isotopes of the elements have been given only one place in periodic table, although they have different atomic masses. Elements with similar properties are placed in different groups. Both copper and mercury resemble in many properties, but they have been placed in different groups. Some dissimilar elements are grouped together. Coinage metals like copper, silver, gold, group 1b are placed along with the alkali metal lithium, sodium, potassium group 1a, although they have a different properties. Modern periodic law and the present form of periodic table. Modern periodic law. The physical and chemical properties of the elements are periodic function of their atomic numbers. It means that when elements are arranged in their increasing atomic number, the properties are repeated after certain regular intervals. Periodicity and its causes. Periodicity may be defined as repetition of the properties of the elements after certain regular intervals when these elements are arranged in order of their increasing atomic numbers. The cause of periodicity in the properties is the repetition of similar valence shell electronic configuration after certain regular intervals of 2, 8, 8, 18, 18, 32. These are called the magic numbers. For example, all elements of group 1 alkali metals have similar valence shell electronic configuration of ns1, where n refers to a number of the valence principal shell and thus have similar properties. You can see the alkali metals electronic configuration. You will find there is a single one electron in the outermost shell. Long form of periodic table or Bohr's periodic table. The long form of periodic table or modern periodic table is based on the modern periodic law, and in this periodic table elements have been arranged in order of increasing atomic number. Structural features of the periodic table. Long form of a periodic table consists of the 18 vertical columns called groups, 7 horizontal rows called periods, and 4 blocks SPDF blocks. Groups. These are vertical columns in the periodic table. Elements falling in the same groups have similar valence shell configuration and thus similar chemical properties. There are 18 groups in a periodic table numbered as 1 to 18. Group 1 elements are called alkali metals: lithium, sodium, potassium, rubidium, cesium, francium. They have general electronic configuration of ns1. Elements of group 2 are called alkaline earth metals: beryllium, magnesium, strontium, calcium, barium, radium. They are the elements having a general electronic configuration of ns2. Elements of 15 group elements are nicogens. They have a general electronic configuration of ns2 and p3. Elements of group 16 are called chalcogens. Oxygen, sulfur, selenium, tellurium, polonium. They have a general electron configuration of ns2 and p4. Elements of group 17 are called halogens. Fluorine, chlorine, bromine, iodine, astatine. They have a general electron configuration of ns2 and p5. This is the uh, modern periodic table. It has 18 groups, vertical columns, and 7 periods. Most of them they are metals. On the left hand side, these are metals. These are non-metals, and between these two they are metalloids. Metalloids, they are having a similar they having is both the properties of metals and non-metals. Now, characteristics of groups. All the elements present in groups have same general electronic configuration of the atom. For example, alkali metals present in group 1 have ns1 configuration. The elements in a group are separated by definite gaps of atomic number 2, 8, 18, 18, 32. The atomic size of the elements in a group increase down the group due to increase in the number of the shells. The elements in each group have a generally similar chemical properties because they have a same valence shell electronic configuration of the atoms. Periods. These are horizontal rows in the periodic table. There are 7 periods in the periodic table which are numbered from 1 to 7. The period number is equal to the highest number of principal quantum number of the elements in the period. The first period contains 2 elements. The subsequent period consists of 8, 8, 18, 18 and 32 elements respectively. Characteristic of periods. In all the elements present in the period, the electrons are filled in same valence shell. The atomic size of the element generally decreases from left to right in a particular period. In a period, the metallic character of the elements decreases while the non-metallic character increases. Thank you and have a nice day.